G'day everyone. As a developer, shifting security down on a multi-agent system has felt like trying to navigate the Vegas Strip at midnight, blindfolded. You don't always know what vulnerabilities are critical or how an attacker might manipulate your planner agent into routing 10,000 marathon runners straight through a Vegas casino. I'm going to show you how to govern agents with easy-to-understand policies. You'll also see how to identify exploitable risks in your code and how to fix them. Our agents have been deployed to Agent Platform. Agent gateways are proxies between agents. We already have a gateway in place for our simulation. Agent Gateway enforces identity and access management policies, or IAM policies, to help ensure that agents are only accessible by approved sources. This is the agent registry. Our planner and simulator agents are already listed here. Each agent instance has an identity, which is automatically generated when the agent is deployed. Now, unlike broad-purpose service accounts, agent identities provide a unique and immutable credential for each individual agent. Think of service accounts like a single all-access hotel key that's shared by the entire marathon event crew. What a bad idea. Agent identities are like having a biometric scanner at every door and are fully auditable. Here we see our policies. These egress agent policies govern outbound traffic from an agent to resources like tools, models, and other agents. Egress policies are the guardrails for our agents. Our gateway is already configured with a strict policy in place, blocking the planner from accessing the open internet. When you're feeding an agent 10,000 live runner profiles and our production API keys, what happens in the planner needs to stay in the planner. But we still have a problem. Emma showed us how she's able to change our budgets. While I appreciate the agent's generous spirit, we can't have it treating our budget like a high roller suite. We're going to add a policy to our planner agent. So we're going to hit create. We'll select our planner agent from this list here. And there we are. The planner agent calls an MCP server with tools for reading and writing to the financial database. So let's go ahead and select our finance MCP server here from this list. And then we're going to go and add a condition. We'll name it read-only finance. And we'll set the read-only value here to true. We'll hit save and we'll hit create. Now this can take about 5 minutes to propagate, so I'm going to switch to a version that I deployed earlier. Now let's try the same prompt that Emma entered. The planner agent is communicating through the agent gateway, and thanks to our new policy, it can no longer call write-enabled tools on the finance MCP server. And there we have it. Sorry, Emma, I'd love to approve the glow sticks and sunglasses, but our zero trust architecture comes with a zero budget policy for impromptu spending. In just a few steps, Agent Platform has enabled us to implement role-based access control for our agents using agent identities and policies. But let's switch gears. Thanks to all of these agentic developer tools, I'm writing a lot of code. But how can I be sure that my code is secure? To show us how to help keep all of our code secure, all from within our developer tools, please welcome to the stage Founder and Vice President of Product at Wiz, Inon Kostica. Give it up for Inon.
Thanks, Ankur, and for the opportunity to present to the amazing development community here at Next. Wiz is a unified cloud security platform that helps organizations secure everything they build and run. Wiz scans your code and infrastructure to build the security graph that's a living map of your cloud and AI applications. We use rule-based, but also the latest AI models to understand risks and vulnerabilities to the environment. On top of the graph, Wiz uses context and a layer of security agents that accelerates the security work. In yesterday's opening keynote, we showcased the Red Agent. The Red Agent is our friendly pen tester that exploits issues from the outside. Next, we showed the Wiz Green Agent. That's a fixer that suggests root cause remediations and starts the dev workflows even directly to our coding agents.
And look, we can see our marathon planner agent, the model it runs on, and the tools it can access.
Yes, exactly. This is a full architecture. So while you were building your app, security can easily see what you've built, understand it, without you having to actually explain it to them. So we can see also not only the agent is here, but also there is a full attack path from the internet through this internet exposure all the way to sensitive data behind it. Now, the Red Agent looks at this attack path and validates that the risk is actually exploitable from the outside. You can see that it found an authentication bypass vulnerability, and more than this, you can actually see all of the steps it took in order to find this authentication bypass. So in general, the AI attacker, the Red Agent, is the best AI attacker probing your environment, and it goes far beyond code analysis to focus on real risks to your deployed apps and APIs. Now, with our cloud-to-code inference, we can actually identify the source repo to actually fix it.
Now, as a developer, I want security to meet me where I work, in my dev tools, without going to a security portal. And with Google Cloud and Wiz, I can use any AI tool I want to help with security work.
Perfect. So here we have Cloud Code with Opus, and with Wiz we want to enable your choice of tools and models as long as you fix and prevent real risks in your applications. And now, we just saw a critical risk to our planner agent that Wiz says we should fix right away. We can use a Wiz skill. You can see here the Wiz remediate that basically I ran earlier to pull all of the risks deployed from this repo. Now, you can see that Wiz found a toxic combination that's a critical risk. You can see 7 distinct security risks that actually created this attack path. Now, the Wiz Green Agent looks at this attack path, and it actually suggests 3 priority fixes to break the attack chain. The first one is to downgrade the AIM privileges. Second is to patch the authentication bypass vulnerability. And the third is to enforce the AI guardrails.
Now, as the human in the loop, I love the control and practical sequencing. So let's go ahead and apply these changes in on.
OK, so now this takes a couple of minutes to run. So I'll switch to one that we've already run just before. And it looks like Cloud Code has already applied all of the fixes. You can see the changes, but you can also see a summary here that it actually found the Terraform to remove the excessive access. It actually found the application code to patch the authentication bypass vulnerability, and it enforced the AI guardrail. Et voila, basically code findings turned into actionable code fixes grounded in runtime exposure and actual attack path context. Now we can commit the code, Wiz does a rescan, we can see that it passed, and we're good to go. This is what it means to build faster and safer than ever before.
That was amazing. Thanks, Inoam. That's great. In this demo, yeah, give it up. In this demo, you saw how Agent Platform enables fine-grained governance of agents with Agent Gateway as a proxy, role-based access control, identities, and policies.
You also saw how Wiz can proactively scan your code for risks, then identify if they are actually exploitable, and guide you on how to fix them, all from your own developer tools.
This is true secure development. We no longer have to choose between developer velocity and security.
Let's do magic.
Take us to the finish line, Richard and Emma.